Hello, this is part 2 of our lesson on permutations. In this video, we will talk about distinguishable permutation. There are problems in which objects are duplicated several times. Say the word maataw, where A is duplicated 3 times. So how are we going to solve this? Generally, say we have several types of objects at hand, such as A sub 1, A sub 2, up to A sub k, with a total of n objects. Type A sub 1 is duplicated n sub 1 times. Type A sub 2 is duplicated n sub 2 times. Type A sub 3 is duplicated n sub 3 times, and so on until type A sub k is duplicated n sub k times, where the total of all n sub k is equal to n. The duplications are eliminated by dividing the factorials of all n sub k. By definition, the number of distinct or distinguishable permutations of P of n objects where n sub 1 objects are alike, n sub 2 objects are alike, n sub 3 objects are alike, and so on up to n sub k would be this formula, where n is the total number of elements in a set or the total number of objects. The exclamation point indicates factorial, and n sub 1, n sub 2, n sub 3 up to n sub k are the number of times a certain type is being repeated. Let's have some examples. Say we have 9 letters at hand. How many 9-letter words can be formed regardless if the word has meaning or not? Well, we must consider that the 3 F's are alike, the 2 G's are alike, and the 4 H are also alike, meaning F is duplicated 3 times, G is duplicated 2 times, and H is duplicated 4 times. Substituting the values above to our formula, we have P, the permutation of 9 objects, taken all of them at a time, such that one object is duplicated 3 times, another object is duplicated 2 times, and another object is duplicated 4 times. Now this is equal to 9 factorial divided by the product of 3 factorial, 2 factorial, and 4 factorial. 9 factorial is equal to 9 times 8 times 7 times 6 times 5 times 4 times 2 times 1, and this will be divided by the product of the factors of 3, 2, and 4. Evaluating further, we can notice that we can cancel out 4 times 3 times 2 times 1. You can also cancel out 6 in the numerator because 6 is equal to 3 times 2 times 1. And so we have 9 times 8 times 7 times 5 divided by 2 times 1. And it is equal to 1260. Therefore, there are 1260 permutations from the 9 letters. So for the word maataw, we consider the duplicated letters. A is duplicated 3 times, while M, H, T, and O are repeated only once. And so, we have the permutation of 7 objects, taken all of them at a time, such that A is duplicated 3 times, M, H, T, and O are repeated only once. And this is equal to 7 factorial divided by the product of 3 factorial, 1 factorial, 1 factorial, 1 factorial, and 1 factorial. Evaluating further, we have 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1 times 1 times 1 times 1 and times 1. But since 1 factorial is equal to 1, and then we have 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1. Evaluating further, we can see that we can cancel out 3 times 2 times 1. And so we have 7 times 6 times 5 and times 4. And this is equal to 840. Therefore, there are 840 permutations for the word maataw.